Hi, I'm Mrs. Lemke, and I'm here today to talk to you about systems of equations. Lately, we have been talking a lot about graphing parabolas, and in this lesson, we're going to take a step. It might seem a little backward, but we're going to go back to when we just had lines, and we're going to look at what are called systems of equations. Our very first question asks us, what is a system of equations? And a system of equations is just when you have two or more equations that have two or more variables. So an example, just provide your own example. An example would be if I had like x plus y equals 5, and then I had y equals negative 1/2 x plus 4. I just made that up, okay? So I have two equations, and each of those equations has x and y, okay? So that's the idea. I have a problem that has more than one equation, more than one variable. So in the next problem, it says, if I have a system that is given by the equations y equals x plus 4 and y equals negative 2 minus 2, plug in plug in negative 3, 1 into both equations separately and describe what happens. So in this, negative 3 is my x, 1 is my y. So I'm going to take this first equation and I'm going to plug in my y value, which is 1. Instead of writing x, I'm going to write negative 3 plus 4. Okay, well, I know that negative 3 plus 4, this side, is equal to 1. So I got 1 equals 1. That's true. 1 does equal 1. If I plug into the other equation that starts out with y, and my y coordinate is 1, then it says the opposite of x, my x is negative 3, minus 2. Well, the opposite of negative 3 is positive 3, and 3 minus 2 is 1. So again, I got a true statement. So when I plugged in that ordered pair, I got two true statements. What this indicates, my friends, is that this ordered pair is what's called the solution to this system. It is the pair of numbers that makes both equations true. What that means on a graph is what I'm looking for is the point that is on both lines. So here I have a green line, here I have a blue line, and they intersect right here. So where they intersect at negative 1, 1, that is my solution to the system. So the equations that made those graphs, if I plugged in negative 1 and 1 for x and for y, I would get true statements. So let's look at number 4. Number 4 actually gives me two things to graph, and I need to remember some things about graphing lines here. Remember how y equals mx plus b is one of the forms a line can be in, and that this m is my slope, and this value is the point 0, comma b as my y-intercept. You need to remember that from a previous life. Okay, so my first equation is y equals 1x plus 1. I did emphasize that extra 1 in there. Just an x means 1x. So that means my first equation has a y-intercept at 1, and then I go up 1 over 1, up 1 over 1, up 1 over 1 to get more points. Or I could go down 1 and back 1. Same idea. Okay, but that is the line that that equation is describing. This line right here. And the other equation has a slope of negative 1/2 and a y-intercept at positive 4. So here's positive 4. Then I want to go down 1 over 2, down 1 over 2, or vice versa, going back the other way, okay? And so that line I can see is tilting the other direction. because it has a negative slope. And we can see the point of intersection is right there. I drew it. I drew it on both of them. It's this guy right here. So my solution is 2, 3. So as nice as it is to get a visual of graphs, right? Sometimes we don't like to have to graph. I mean, graphing is fine, and we can draw graphs, but sometimes it's a hassle to have to draw. And so it would be nice if we could find solutions in ways that didn't involve drawing. And in Algebra 1, you studied one such method. It is called substitution, and I'm going to review that with you now. So in substitution, you want to have one of your equations be in this kind of format. What I mean by this kind is like you have y equals and then blah, 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 or you have x equals and then blah, blah, blah. This is the ideal kind of situation if you want to do substitution. Okay, there's going to be another technique we talk about. We already talked about graphing. Graphing is its own technique too. There's another technique we'll talk about that doesn't really require this setup at the beginning. But if you're going to do substitution, you want to have an equation like that one I just highlighted. Okay, so what that is saying is in place of y, I could write x minus 1. So in the other equation, which is 2x minus 3, and then here is my y equals negative 1. Instead of writing y, I could write x minus 1. So instead of this y, I'm going to write x minus 1. Now, if you look at the equation I just wrote all in green, there's only one letter involved, one variable, just the x. Now this problem is much more doable. Okay, so I'll distribute my negative 3, and I'll have 2x minus 3x. Now, negative 3 times negative 1 is positive 3, and that'll be equal to negative 1. I'll combine like terms. I'll subtract 3 from both sides. And I'll divide by negative 1. And that will leave me with x equals 4. Now, the thing is, we're really used to having that be the final statement in a problem, like find x, yay, done. But you have to remember that system of equations questions are asking for locations on graphs where things intersect. So I need an x and a y. So go back to your problem and notice that it says y equals x minus 1. I am having such technical difficulties right here. Y equals x minus 1. And so if x is 4, that means y is 3. So that is the other part of my answer. I have to have both parts. I need to say at 4, 3, that's going to be the location where these two graphs cross, where those two lines intersect. All right, the next problem is one for you to try yourself. Please pause the video, work the problem, and then come back and see if you got it right. Okay, so hopefully you did the problem already. If you didn't, please just try taking this first step and then pause again to see if you can get past this little beginning step, okay? The beginning step is a little tricky at first. So it says that y equals negative 3x plus 5. So where there's a y up here, I can put in negative 3x plus 5. Right? So I substituted in. It's as if I am reading. My eyeballs right now are going along this equation. And when I read y, instead of that, I write negative 3x plus 5. Okay? And then after that, we're going to distribute that negative 4. And you will get the next line in green. Watch your signs, combine like terms, and you get 17x minus 20 equals negative 3. Add 20 to both sides. Divide both sides by 17, and you get 1. And then my work came over here, to the blue. So if x is 1, go to the equation that says y equals, put 1 in for x, and find the y, and you should get the solution 1 comma 2. Right, in the next problem, you're actually given a freebie. Okay, I'm not going to do this whole problem, but I would just like to point out, they already told you what y is. So all you have to do in this question is find out what x is. Your answer is going to be the answer for x, comma, -2. Okay, so that's kind of a freebie that you could just save that as a practice problem. This one is a little bit more complex, so I'd like to do this one. So here it says y equals this. We're going to put that in place of the y. Okay, so I'd like you to pause the video, and all I want you to do are the first 2 steps. Plug in and distribute. That's it. Then come right back. Okay, so you should have plugged in and distributed. And I wanted you to come back because look at what weird thing is going to happen here. We're going to have 12x and then we're going to subtract 12x. Well, that makes 0. So I get 36 equals 24. Does 36 equal 24? No, that's not true. Okay, so if you get something like this where you get a statement that literally is not true, what that means is that your lines must not cross. Your graphs don't intersect. So there is no solution. These 2 graphs do not cross. Okay, they do not cross at all. All right, now all of that you should have encountered in your Algebra 1 class. This I'm not so sure you've seen before, okay? This is what's called the elimination method of solving a system of equations. So in the elimination method, rather than looking for having y equals blah, 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 or x equals blah, 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 what you want to do is get your equations to have the pieces that correspond kind of matched up. So this is what I mean. This first equation has the x part, and then it has the y part, and then it has an equal sign, and then it has a number. Okay? I am going to adjust the second equation so that's also true. The x part is already on the left. That's great. I want the y part to be over on the other side. So I would subtract 2y from both sides to move that 2y. And I'm going to subtract the 3 to move it to the other side, like that. Okay, now if that was confusing to you, you always could write more than I did. Okay, so for instance, I have x plus 3 equals 2y. The order doesn't matter there. Subtract 2y from both sides. I'd have x minus 2y plus 3 equals 0. And then this 3 would be subtracted from both sides, right? And that's how I got the part that's in green. And that just seems like a lot of writing, but if that's what you need to do in order to understand what's up, that's what you need to do. Okay, so I've got my equations in a form where they match. So if I'm looking up and down now, these are both x's, these are both y's, there's my equal sign, there's my numbers, right? Everything is like lined up and down. That's what you need to do in order to use elimination. Then what you want to do is look to see if I were to add these equations, would anything cancel? And the answer to that is no. 7 and 1 don't cancel, 6 and -2 don't cancel. However, if I were to take this whole second equation and multiply through by 3, look at what magic happens, okay? So I'm multiplying both sides of this equation by 3. The top equation is not changing. That's still what it is. But this bottom equation is going to become, let me get a new color for that, 3x, so I'm distributing the 3, minus 6y, because I'm distributing that 3. And then over here, I'm also multiplying by 3. That would be -9. Okay, now look at these last 2 lines that I just wrote. Okay, look at the lines that I put stars by. Those 2 have something that's going to cancel now if I just add. I'm going to add the equations to each other. So 7x plus 3x makes 10x. positive 6y plus negative 6y, that's going to cancel. And that's what you look for in elimination. It's called the elimination method because something gets eliminated, removed. And then over on the right side by my stars, I've got -1 plus -9, which is -10. So the equation I have here, I'm just going to write it without that extra space. The equation I have is 10 times something is -10. X is -1, right? Divide both sides by 10 if that's how you want to think about it. So X equals -1, and I can't get too excited about that and think I'm done because it's a system of equations problem. I need to find X and Y. So I'm going to, you could pick either equation. I'm going to pick 3 plus X equals 2Y. And I'm going to substitute in for my X because it said X equals -1. Make sure you put it in for the appropriate variable. So 3 plus -1 is +2. So 2 times y is 2 means that y has to be 1. So my complete solution is the ordered pair -1, 1. We did that with elimination. Remember, with elimination, you want to have things matched up vertically. So you have the x terms, the y terms, the equal signs, the constants, like all lined up. And if nothing's going to cancel, you multiply through by something so that, oh my goodness, I keep doing that. You multiply through by something, like the 3 in this case, so that you do have numbers that are the same but different signs. Okay, and that is what causes the elimination to occur. Okay, let's do this next one together. All right, so in this one, it's actually easier because we have the x's already lined up, the y's already lined up, the equals, and the numbers. It might not seem as obvious because my typing of this worksheet is a little janky, but if you really deal with the spacing issues, that's what we have to start with. And if I add these right now, I'm good to go because the x's are going to eliminate. X plus -x is 0. 2y plus -4y is -2y. And 4 plus -14 is -10. So this tells me that y equals 5. And I can go back to either equation. I'm going to pick this top one. Doesn't matter, your choice. And I'm going to put in the value of y as 5. Notice it said y equals 5, so that's where I put it in. If it said x, I plug in for x. And this would be x plus 10 equals 4. If I subtract 10 from both sides, I get x equals -6. So my final answer is -6, 5. That seems pretty doable. Okay, there are a few more questions here. Question 11 is a new question type. This is something you would see on a standardized test a lot. So instead of asking you to find x and y, they ask you to find this other thing. You find x, you find y, and then you make sure to answer that. Okay, I'll show you what I mean. This is already set up for elimination. And the reason it's set up for elimination is if I add right now, the x's eliminate. So I'd get -2y equals -8. So y equals 4. And then if I come back to the top equation, let's say, instead of writing y, I'm going to write 4. I would get 5x minus 24 equals 6. And so 5x would equal 30. So x equals 6. So 6, 4 is the solution to the system. But the question was to find 2x plus 3y, or 2 times 6 plus 3 times 4, because this was my solution, or 12 plus 12, which is 24. So standardized tests like this kind of question because they can just have a list of single answers instead of ordered pairs. And it also is a lot harder to like go backwards on. So like if they give answer choices like that, you might just plug them in and see which one worked. This is much harder to do that. All right, there is another pair of questions like this. I would like you to pause and then come back and check your answers, and then you are done listening to the lesson. But please try these two on your own first. Okay, here's my work for number 12. I'd added the equations as they were because then the y's canceled. I got x was 2. I later plugged that back in. I got y was -2. And when I put those values into the expression, I got -8. In the last question, I multiplied the bottom equation by -3. That is not the only way you could do this problem, but it is the way that I chose to do it. This allowed the y's to cancel. I got that x was -2. And then from there, I followed my little red arrow here. I plugged -2 into one of the equations. And I got from that y was -4. So x is -2, y is -4. And when I substituted those values into the expression that was requested, I got the answer of 10. Okay, feel free to pause on this question, or you could pause on the previous question. Either one, if you need help with either, to fill in your notes. And thank you for listening to this lesson, and good luck with your assignment. Thank you.